I'm Evelyn Hayes and I'm a Principal Consultant at Thorogood. In this session, I'm going to be looking at analytics with Amazon Web Services. Amazon Web Services is a key provider of cloud infrastructure, the leading provider. And really what we're looking at here is just the analytics that you're able to do with it. So brief agenda, I will give a quick overview of AWS, Amazon Web Services. I'll then focus in on some of the offerings it has around the analytics space and then walk through a use case with it. So you've already seen this slide from Trevor. I won't go into it in too much detail, but Amazon Web Services is the market leader. It had first mover advantage and has maintained that from a revenue perspective, but is also recognized by Gartner as being the leader in terms of cloud infrastructure as a service. I think from the customer point of view that AWS services have proved to be extremely flexible and scalable, and it's very suitable for large companies and small companies as well. And the fact that it's got its data centers in regions across the world means that it has that consistent availability for support and response. A number of our customers are using AWS, but if we just look at some of the major well-known brands that are on AWS, I think it's very interesting the way that it's being used. So Netflix uses AWS for nearly all of its computing and storage needs, including the databases, the analytics, and its recommendation engines. So in fact, everything up until the point you press play is running on AWS. Kellogg's, similar to a lot of consumer goods companies, spends approximately a third of its annual revenue on trade promotions. And so Kellogg's uses AWS to store and analyze the vast amounts of data that it uses to be able to evaluate promotional effectiveness and ensure that it's placing its money in the right place. Lyft is a good example of a virtual business using cloud technology, so in this case AWS, to really minimize any IT and infrastructure costs within the business. So Lyft launched in 2012 on AWS, and it really makes full use of the scalability that AWS provides. So that could be scalability in terms of just on a daily basis to be able to cope with peak periods of bookings, but also when it was expanding. So as an example, it launched in 24 new cities overnight in 2014. Using the scalability that AWS offered. Another example, General Electric, they have selected AWS as their preferred cloud supplier, and they started an enterprise-wide migration to the cloud. Their CEO in 2015 came up with a great quote that AWS is our trusted partner that is going to run our company for the next 140 years. Not quite sure the significance of 140, but it's a lot of years. And finally, from these examples here, NASA. So NASA uses AWS to capture and store images and metadata that's collected from the Mars Exploration Rover and the Mars Science Laboratory missions. Mars the planet as opposed to Mars Incorporated, Trevor's been talking about. And there are many other global companies that use AWS. Apple, for example, apparently spend more than $30 million a month on AWS. But it's not the only cloud that they use. So they also use Microsoft and Google. So as Trevor was referring to earlier, that you're not tied into any one particular cloud platform. Apple picks and chooses the components that he thinks is most suitable for particular applications. So let's have a look at a high level of the Amazon Web Service products. So this is the diagram that they use on their website to group their products. And what I'm going to do is just pick out some sort of particular offerings within each segment. Some of the offerings are available in different segments, but basically there are a lot of offerings within AWS. So what I was going to try and do is just pick out sort of pertinent ones in terms of business intelligence and analytics. So if we start off with compute, we've got Amazon EC2, which Trevor has already referred to, Elastic Beanstalk, and Lambda. So EC2 provides the compute capacity in the Amazon cloud, which can be scaled up and down as needed, so very flexible in that respect. Elastic Beanstalk provides a service for deploying web applications and scaling them. And Lambda is a very useful service. It provides serverless code hosting so that you can run code in response to events. So really, you only end up paying for the compute that you use. From a storage perspective, we have S3, or Simple Storage Service. And this is really what we're seeing from our customers' use and for our own use. It's one of the simplest yet most powerful offerings that we see. So you can create data lakes in what's called an S3 bucket, and tools such as Tableau, for example, can connect directly to the data. Or you can put unprocessed streaming files or raw data files into S3, and then you can transform and clean that data and move through buckets within S3 or into a relational database. We've got Amazon Glacier, so that's a low-cost storage service that's really useful for backups and archiving. And Elastic Block Storage, so that's designed for workloads that really benefit from fine-tuning. From a database perspective, we have Amazon RDS, Amazon Redshift, which probably most of you have heard of, and AWS Database Migration Service. So Amazon RDS, or Relational Database Services, is a managed database service on cloud, which means that the hardware, the database setup, the patching, the backups are all managed for you. And it supports a number of database engines, so that includes Oracle, Microsoft SQL Server, and many open source relational databases. Redshift is their cloud-based data warehouse tool, which really allows for massive storage with really fast query response. And database migration services help to migrate databases to AWS. So that could be on-prem databases migrating to AWS. It could be homogeneous migration, so from Oracle to Oracle, or it even supports migration from, for example, Oracle to Microsoft SQL Server. And then finally, we have a number of offerings within analytics and machine learning, which really do help to get data in, to enable you to structure your data and to run the machine learning algorithms to perform the analytics. I'll go into these in a bit more detail in a minute. So in terms of the looking at the AWS Analytics offerings, I find it's useful to actually step back and look at the approach to analytics and therefore how these offerings fit in. At Thorogood, we use the CRISP DM approach, so the cross-industry standard process for data mining. And it really fits in with our general philosophy of really focusing on the business goals, what are you trying to achieve, and mirroring, matching those up with the technical possibilities. So the start is to really leverage your business understanding to identify the questions that you want answers to. And questions that are difficult to answer, but when you do get an answer, you know that it will provide value to the business. And in order to do that, you do need an understanding of the data that is available to you to help achieve that answer. Once the questions have been identified, the data needs to be prepared in a way that really facilitates the modelling that you want to do. Prepare the data, do the modelling, and then come up with the evaluation of the model. And again, this is where the business understanding comes in. So the first iteration might need you to go back and look at the data again. So remove outliers or maybe add some more variables to it. But once there is a model that provides value, it's then deployed to be shared more widely and run on a regular basis. So with that in mind, let's have a look at how the AWS Analytics offerings fit into that process. So the first one we're going to look at is Amazon Athena. Athena is a really powerful tool that can query very large data sets and can run a number of complex queries and analyses. It uses standard SQL for its queries, so it's very intuitive, and it allows us to query the data that we've got sitting in S3 buckets. It can contribute to a number of steps, including data preparation or analysis of data that is output from our models, and provides the ability to take a deep dive into the data in S3, so you can really get rapid exploration and experimentation, as well as identifying other data sources that could be useful for your analysis. The next offering is AWS Glue. So AWS Glue is a serverless, fully managed ETL tool. It integrates really closely with AWS offerings and can allow us to move and transform data across S3 and a number of relational database stores. It provides a really easy way to prepare data for analysis, and it also generates portable ETL code that can be customized to enhance the analyses that you're doing. It can help in terms of training, preparing training data sets for the models. And also, one really useful feature is that it comes with a data cataloging feature that really can help you, contribute to your understanding of the data that you're modeling. The next offering is Amazon Kinesis. So Kinesis really is most useful when you're looking at streaming data or real-time data sources. So that could be anything from monitoring the logs of applications that you've got running. It could be video streaming. It could be Internet of Things sensors, or it could be the collection of social media, and that's where we see it used quite a lot with our customers. It's essentially, data that previously would have been difficult to manage. It makes it easy to access and use that data. And it can be flexible as well, so you can use it in terms of batch processing of the data, or you can have live streaming for real-time analysis. And it has an ability to filter, to aggregate, and to transform the data, so it does reduce the amount of time that you spend within the data preparation stage. And the final product we're going to look at in this section is Amazon's SageMaker. So SageMaker really is a suite for machine learning. And it enables everything from model selection and training through to deployment and hosting. And one of the key benefits of SageMaker is the streamlining of resource consumption throughout the process, so that you really are only using the resource that you need to consume when you need to consume it. It has this auto-scaling functionality, and it really does reduce the barriers to entry in terms of analysis, because you don't have to make the investment in powerful machines to be able to run one analysis to see if it's got any value. You just consume as much or as little compute power as you really need. And SageMaker really does support analysts and data scientists throughout the whole process of modeling, evaluation, and deployment. It can reduce the time to value because it comes with a number of pre-built models that you can then easily customize. And it provides consistency in your platform because you can use SageMaker to move your model from the beginning of exploration right through the evaluation and deployment, all with a unified interface. So let's have a look at a sort of typical architecture that you would use, or we've seen our customers using with AWS, in particular when focusing on analytics. First of all, your data is likely to come from a number of sources, obviously. And the first thing really is to pull these into an AWS S3 data lake. This can be done using Kinesis, where it's the streaming data, or using another tool, AWS Data Pipeline. Within the data lake, typically we'll have three buckets. We'll have raw, we'll have input, and we'll have output. And we'll move the source data into the raw bucket and then use AWS Glue to move it through, to process it through into the input, and then maybe add the dimensionality into the output bucket. So all within AWS S3, but we're using Glue to move and transform the data through the different buckets. And at this point also, we're bringing in SageMaker, where we're looking at the machine learning algorithms based on the data in the input bucket and putting those results also within the output bucket. And then from there, typically the data is moved to Amazon RDS so that you've got it stored in a relational database, again, using AWS Glue. And then finally, in terms of the presentation layer, this is where we do actually see our customers sort of veering off the AWS end-to-end stack. Trevor's mentioned that Tableau integrates very closely with AWS, and we are seeing that our customers are sticking to their sort of tried and trusted tools that they know can produce their results, so things like Tableau, Power BI and so on, as opposed to using QuickSight, AWS's offering. So let's have a look at a use case that we've set up to really sort of work through the different functions that I've talked about. So in this use case, it's a consumer goods company who make a range of products, and they sell those products to a number of different retail outlets. At the moment, not all products are sold at all retail outlets. And what we want to do is actually come up with some recommendations of which products would be potentially most profitable if sold in particular outlets. So we have some outlet information, and really we want to understand the relationship between these different stores, outlets, and use that relationship and machine learning algorithms to recommend the products to each individual outlet which you think would actually maximize the sales and profit, therefore. And also, we don't necessarily want to run this constantly, we want to do it on a semi-regular basis. So we want to make sure that we're utilizing Amazon's pay-as-you-go model to deliver the results most cost-effectively. This is quite a simple example. So the raw data in this case is actually held in CSV files, so I don't need to use Kinesis or Data Lake Pipeline. But the information we have, there's a lot of account information, which includes the sort of typical geographical demographic characteristics of each store and buying patterns that are typically seen there. And we also have information about their nearest neighbours, so nearest geographical neighbours. So, if we've got a Tesco Express and we've got a Sainsbury's local store next to each other, then they will be identified as neighbours there. So in terms of the steps to work through, the first step is basically just let's get the raw data and get the source data and put it into an S3 bucket. So here I've set up 4 buckets actually. I've set up a raw, an input and an output folder as per the sort of standard architecture diagram. I've also got another one which is a repository. So that's where the code that I'm going to be using will be stored within that S3 bucket. The next step is to actually then get the data from the raw into the processed output. So I've got a demo here that I'm going to run. So what I'm doing here is I'm choosing the source files that I've put into my, or uploading them into my raw S3 bucket. But these files, they have to be transformed and merged into a single file and saved into an output folder. So the process here, it's currently uploading the data files into my first S3 bucket. And once they are there, I'm then going to transform them using a glue job. So once this is finished, if it ever does, there we go. I'm now going to go to my glue job, and this is triggered by a lambda function. So the processes take place to start transforming my data and merging the 3 different source files into a file single file within my input bucket within S3. So the processes are currently running here. So this is within the Glue console, and then when those are finished, we'll go back to the S3 console and go to our input bucket and refresh, which always confuses me because it says it's empty and it's not. Refresh it, there we are, and then we've got the transformed data within our input bucket in S3. The next step is where SageMaker comes in. So this is SageMaker code that's written in a, the code is written in a Jupyter notebook in SageMaker. And SageMaker, the power of SageMaker, that you can use this consistent interface all the way through. So the files are read from the input bucket that where we just put them. We're doing some cleansing on the data. We're then normalizing the data, so really getting it in a suitable state, ready for the analysis or the modeling that we want to do. We're reducing the dimensions using principal components analysis, so just making sure that we're not looking at the vast array of dimensions, we're just looking at pertinent ones. So by combining, for example, store size and total sales, which are probably quite highly related. And then finally, we're using the k nearest neighbours algorithm to identify the nearest neighbours and to be able to predict the products which we think will sell well in particular stores. And then those results are then stored in the S3 output bucket that I've created. The next step, if you remember the architecture that I showed, is then, so we've got the process and the recommended data within our output bucket in S3. Next step is really just to push that through to RDS. And again, we're using Glue. We're using Glue Crawler and Glue Data Catalog to make sure to put this data ready into our semantic layer, if you like, into RDS, so that we're ready to query it. So Glue job is run to load that data into RDS. And then the final step is then to report on that data from the RDS data store. And in this case, I'm using Power BI. So if I just switch out of here and go, so very simple dashboard that we've set up here to look at the results of the recommendations that I've just run through SageMaker. So in this case, at the top here, I'm looking at a particular retail outlet. It's showing me the products that this outlet currently purchase, but it's more importantly, it's showing me the products that it recommends it could purchase. And in this case, these 10 different products it's saying that it could purchase and think that the model predicts will sell well, and it's also ranked them in order of precedence. So it's really telling me that SKU 56, that well-known brand, is likely to do very well in this particular store based on the similar customers that it's identified, and it's given me some information about the similar customers here. And if I switch to a different retail outlet, again, it's showing me the products that store currently purchases and the recommendations here. So in this case, it's showing me 8 products that it recommends could sell well. And SKU 57, it seems to be the top one there. Okay, it's a very simple example there, but in terms of the dashboard, but hopefully gives you a flavour for it. So just to summarise this use case, it seems that when I was putting this slide together, I thought, wow, that's a lot of different steps it goes through. But these are all within, up until the point of Power BI, these are all within the AWS stack. So we're using S3 to store the data. We're using Lambda to trigger events with Glue when new data arrives. And for the actual machine learning algorithms, we're using SageMaker. The output of all that is put into RDS. In this case, we were actually using SQL Server. And then, obviously, showing the results through Power BI. Just wanted to finish on a sort of final sort of, consideration, really. This title is pretty generic. It could apply to any particular situation in IT, really, couldn't it? Choosing the right tool for the right job. But I wanted to use an example because AWS does have so many different offerings that you can achieve something in many different ways, but it is a question of picking the right tool for the right job, particularly if you want to build a robust and scalable platform and you want to make sure that you're thinking about the things that are important to you, be it cost, be it speed, and so on. So we've talked a lot about AWS Glue. It's serverless, it's fully managed by AWS. You can create and run an ETL job with a few clicks within the AWS Management Console. You can simply point it at your data sources, your data stored in AWS. It discovers your data, it discovers the associated metadata, and it stores it within the data catalog. So AWS Glue is really useful when you do require data cataloging and you really haven't got particularly complex transformations. There is another offering, Amazon EMR, Elastic MapReduce, and this requires manual cluster configuration. It's cheaper to use than Glue, but that's because of the added complexity, and it doesn't support real-time collaboration, or it doesn't keep sort of your history of your trained models. EMR is best used probably if it's really complex transformations you want to take place, or if you're really talking about petabyte scale processing of data that you need to happen really quickly. So from a very crude point of view, AWS Glue is very good for the data engineering capabilities within the stack. EMR is very good for the data science capabilities. So there's a particular choice to start off with. But leading nicely on into John's section, there are other tools available. And Databricks is one that we're really seeing a big pickup in usage of because it has that ability to be used for both data engineering and data science capabilities.